Here we are in section 1.2 with the answers to numbers 13 through 27. Number 13, 5.234, 234, 234, that is definitely a repeating pattern, which means it is rational. Yes, we could turn this into a fraction, and it is also real. Number 14, this is negative whole number, so that means we are in the integers. So that's a z, and that is definitely a q, since all integers are fractions, and we're definitely a real number. Here is the seventh root of 3. What number times itself 7 times to equal 3? Definitely not a nice number. It doesn't come out nice, so it is irrational. So that is irrational and real. Everything is real, so better be on each one of them. All right, 38 thirds. That's a fraction, so it's definitely q. Does it come out nicely? No, it doesn't. 3 does not go into 38, so it is not an integer or anything better than that. All right, pi squared, that's a special, unusual, weird number, and we use pi because it cannot be written as a fraction. So that is definitely irrational and, again, real. All right, number 18, square root of 900. Does the square root come out nicely? Yes, it does. It's the number 30, which is a normal counting number, which normally just natural. And so it's also whole and also integer and also rational and also real. Excellent. 0 over 17. What is 0 over 17? This equals 0, which is just a normal number. It is not natural, however, so it is just whole, and then everything bigger than that. Integer, rational, and real. Good. The square root of 1,000. Ooh, that looks like it should come out, but it doesn't actually come out. That is an irrational number and real. Put that in your calculator and you get a decimal that never stops and never repeats. Number 21, negative 53.741. This decimal, look at that. It stops, so it is indeed rational. And we can tell it's not a natural whole or integer because it has a decimal portion on it. So that's rational and real. 7.334, 334, 334, that repeats, so it is obviously rational because it has a repeating decimal. So rational and real. Everything's real. All right, 2.53, 553, 5553. So this is not a repeating pattern such as this. This is a pattern that changes each time. So it is irrational and, of course, real. It is on the real number line. And the cube root of 11. Is that a nice number? It is not. So again, that one is irrational and real. All right. Describe the numbers that are in Z but not in N. So natural numbers, these are 1, 2, 3, go on forever. And this one, you include 0 and the -1, -2, -3. So these guys are 0 and all negatives, no fractions. So that should be in the explanation. So you should have 0 and all the negative natural numbers. All right, describe the numbers that are in Q but not in Z. Now, Z is everything that's nice. So -3, -2, -1, 0, 1, 2, 3, right? Right. Q are all the fractions. So these guys are everything that is a fraction that does not simplify to an integer. So this fills in most of the holes between all of the integers. The integers are like the even numbers, and the fractions are all the things in between. How can you tell the difference between rational and irrational numbers? Rational numbers are decimals that repeat and or stop. That's what it is. Decimals that repeat or stop. So these guys don't repeat and don't stop. So these are square roots that negative do it. How can you tell the difference? Rationals can always be written as a ratio of two numbers or fractions.